Welcome back. This is one of the most important concepts in the area of chemical equilibrium. I'm trying to keep it as simple as possible, but that doesn't mean I'm going to provide some of this information in the appendix, something you have to memorize. Okay? And if you get it wrong, you're going to get it wrong all the time. Okay, so memorize it right the first time. All right, so here's the question, here's the problem. And I'm asking you what can be inferred about the reaction. What I'm really referring to it, again, that's a very poor way of writing a question. I will improve my writing in the actual problem when I put it on a homework or a test. But what I'm really asking is, the reaction currently as it is sits is at equilibrium. Now, if you change the reaction conditions by changing the concentrations, are you going to go to the left more, or are you going to go more to the right? You're saying more. Okay, you're not going to just go to the left and go to the right. Okay, that's a misconception. You're going to make more of one or the other. Okay, are you going to go more to the left, or are you going to go more to the right? Okay, so first order is always balancing. So 1, 3, 2. Okay, now this is the Kc, which is the original concentration, which is the original equilibrium value. Okay, let's say we give new concentrations. What would be the K value, and then how does it compare to this? Okay, and this is a condition you would have to remember. I will not provide this. Okay, I'm going to call the new value as K new, but the expression would stay the same. That doesn't change. Okay, it'd still be the same. But we're doing new concentration, right? So that means we put the new values in. So it'll be 0.3 squared over 0.2 times 0.15 cubed, right? You put that all in the calculator, you get 133. Okay. Now clearly K new is greater than Kc, right? That is 113 is greater than 0.5, right? So if K new is greater than Kc, the reaction will move towards the left. That is, this is the left, this is the right. The equilibrium will start to shift towards the left more. Doesn't mean it's going to go to the left and stay there. It will start to fluctuate towards the left side. That means product concentration will decrease. To us, this is the reactant always, this is the product always, right? So that means product will decrease, reactant will increase. That's all. Okay, so this is the condition. This is the answer. What can be inferred about the reaction? The reaction equilibrium will move more towards the left, and that's it. Isn't that easy? All right, so stay tuned for the last video on the first subset of topics for equilibrium. I will post the second subset, which would cover the remaining portion of equilibrium in the second set of videos. All right, so stay tuned for the last video on this first subset of topics on equilibrium.